Okay, I was going to make a video to work out number 12 on page 59. This is one of the problems that you have in your assignment. So, put up a screen to do this on. So this particular problem, we're looking at page 59, number 12. What you have here is you have coordinate plane, and you have a point R, which is 1, 3, and they give you a second point. Well, they tell you part of a second point. They tell you point S is 6y, and they don't tell you the y coordinate. So without knowing the y coordinate, we don't know vertically where it's placed. We just know that at 6, somewhere along this vertical line out here at 6 is where that needs to exist. And the last detail you're given in this problem is the length is 13. So it could be 13 units and it lands right here. Or it could be 13 units down here and it ends up landing down here. We just don't know which. So we don't have to, I'll just make that a solid line. They may not look quite like they're the same length, but they're meant to look like they're the same length. They're supposed to be 13. So the algebra will find these two different points for us, and it's going to help us by going through the distance formula. So you don't have to set up two different equations, but you do need to use the correct formula. And so distance formula is x2 minus x1 squared plus y2 minus y1 squared, all inside that radical. And we are going to start plugging in some values. So we need to, first of all, identify what our first pair is. So I'm going to call this one down here 1, 3, my first pair. So that will be where my x1, y1 values come from. And this will be my second pair. That'll be where my x2 and y2 values come from. So let's start plugging things in. We have 13 for our distance. We need x2. So from the second pair, the x value is 6 minus x1. So from the first pair, that's 1. That's squared. Now we're subtracting the y values. So second y is the letter y, the variable, the unknown, and the other is 3. Okay, so that's our setup. And at any point, if I'm going fast, you can pause, rewind, you can go back. So at this point, we need to be able to get some things simplified. And so right now, we can just do a little work inside the radical. 6 minus 1 is 5, and when you square 5, it'll be 25. But this other bit here, we don't want to do a FOIL on that. It's going to make it more complicated. It'll be a quadratic if we did that, which we can avoid because we'll take a square root later to get rid of that. Okay, at this moment here, a little review. If you have something inside a radical, like let's say you have square root x equals 2, remember what you have to do to get that square root to come off the top of the x. You'd have to square both sides, and then that would get us to x without the radical, because the radical and the 2 cancel each other out. And so that's how you get rid of radicals, and that's what's going on right now for us. We want to get rid of this radical on the right, so we're going to square both sides. And when we do that, we get 169 on the left side, and on the right side, you just get canceling. The radical and that cancel each other out. So you get 25 plus y minus 3 as a quantity squared. Okay, so we're getting closer. Right now, then we could minus 25 on both sides. So those cancel each other, and we're going to have 144. I'm going to swap sides right now. I'm going to have my right side go to the left and my left side go to the right. So I'm going to have y minus 3 squared on the left, and I'm going to have 144 on the right. Okay, now another little review here is right now we have a square and we don't want it to be squared any longer. And so remember, if you had something like x squared equals, let's say 16, and you were going to find x, you would have to get rid of the square. And the way you would do that is by taking a square root. And the key detail is whenever we take a square root, we have to add in plus or minus. Because in this case, like we don't know is if x squared equals 16, is that 4 squared equaling 16, or is that negative 4 squared equaling 16? We don't know if it came from the positive 4 that was squared or the negative 4 that was squared. And so in that case, we have to account for both possibilities. And so here we would have plus or minus 4 is the kind of thing from that little example. And these are just examples. So I'm putting them up here to remind us of those properties. Whoa, that looks cool. I just want to move it. There we go. And then I could shrink it a little. All right, I'm not going to try and move any more of it. All right, so in our case here, the way we're applying it is we want to get rid of that square. And so the way we're going to get rid of that square is by taking a square root on both sides. And over here is where we have to remember to put in the plus minus. So with that done, the square and the square root cancel each other. That stuff, y minus 3, comes out from inside that parenthesis. We have the plus minus, and this becomes a 12. So from here, we would have one step left with our adding 3 to both sides. And when we simplify that up, we're going to get y equals 3 plus or minus 12. So from here, if you run the first time, run it as addition, you're going to get y equals 15. Second time, run the subtraction, 3 take away 12, you're going to get negative 9. And we got 2 answers because the positive 15 is the answer for up here, and the negative 9 is the answer for down there. So those 2 answers came out of that idea that we had to have a plus minus from taking the radical. And those are the 2 possible locations when you start at 1, 3 and have a length of 13 and you're locked in with an x value of 6. All right, so that's one of the ones you guys are doing. Hope that helps. See you later.